Hi everyone, my name is Albert. I worked with Ricky and Abbhinav on our final project for DSA called Sliding Puzzle Solver. So the goal of this website that we created was we created two different solvers for the 15 puzzle. You're given a 4x4 grid, then there's going to be numbers ranging from 1 through 15, and you have one blank tile, and so you swap the adjacent tiles with the blank tile to get to the ordered amount that you want. So the goal state that you want at the end is for it to be in the first row, 1, 2, 3, 4, second row, 5, 6, 7, 8, third row, 9, 10, 11, 12, and in the fifth row, 13, 14, 15, with the blank square being in the bottom right. And so the rationale for creating these two solving algorithms and comparing them is to see how these two algorithms differ in how many moves it takes to find this, get to the solution, and the amount of time it takes to find the solution. And so what we did was we found two different algorithms that we found online, sourced from Michael Schrant for the IDA star and Joel Peckham for the greedy solve, and also the Korf paper, which is the person who made the IDA star algorithms. And if you want to take it from here, Abbhinav.
So quick dive into the UI. On the upper right corner, we have the toggle trees button. That it just allows us to determine whether we want to show trees in the bottom two windows or not. That'll just, if you switch it off, that'll help with just the processing power. Then we have the move buttons in the center of the screen. Those just control how the swaps happen and update both grids. You can also use arrow keys to do the same movement. Then we've got the new game button that just starts a new game. And then the shuffler amount, which is a slider that just adjusts the number of shuffles that you want. Usually a higher shuffle amount will correlate with a more complex solution for IDA star and greedy solve. So if you want to test that out, that's also a great way to look at that. Then there's the three buttons for solve both, IDA star solve and greedy solve. Let's just go over what each of these algorithms do. IDA star solve essentially combines depth first search and heuristic guided search. It iteratively deepens the search to find a solution which satisfies a certain calculated cost. The fact that it iteratively deepens to find the solution is what separates it from A star. Greedy solve just uses the pattern database to find the move which has the lowest estimated cost. That's what makes it relatively more simple. Yeah, and then at the bottom, we can see text on number of moves and then the amount of time taken. That just help us directly compare the two algorithms.
So if we look at the two graphs created so these are the two graphs for greedy solve and IDA solve for the same same initial starting board state. And so if we, for instance, just look at the greedy solve button, the green nodes represent the path that it takes to get to the solution, and the red nodes represent the other options it could have taken to get there. The letters stand for which path it could have taken, so down, up, left, right, DULR. And if we click on each individual node, we can see what each of those paths are. And so it'll show you which path it took, so like that. When we compare the two graphs for IDA versus greedy, we're going to see that IDA is typically a lot more taller, but because it's a depth first search, it's going to be able to look at a lot more paths and choose which one is the right path to take. And if we run another example, usually what's going to happen is we're going to see as we increase the amount of shuffles or increase the complexity of our initial puzzle state, we're going to see that typically IDA star takes less amount of moves compared to greedy solve.
Just to elaborate on that, at best, greedy can match the number of moves of IDA star when it also finds the shortest path, but the key difference is that the time it takes for greedy to make a decision at each step is less than that of IDA star. Based on experimental data, we found a roughly even split in which method is faster, with greedy tending to run faster than IDA star as the number of shuffles go up, and vice versa, which can be explained by this trade-off. Here's a bit of experimental data I found if you're curious, and yeah, that concludes our video.